Okay, in this video we're going to look at Unicode XSS 2, and before we start I will just forewarn that this is a very difficult lab. Okay, so let's launch it and try a basic attack. Okay, and in the source we can see that less than is escaped, greater than isn't, and the context we're in, it is an intertag context, but it is within a text area, so that can make things slightly different. But just from this, that we can't inject. Okay, now in Unicode XSS, we tried the ASCII full width less than sign. So let's try that here. Now, it only looks visually slightly different, but you can just tell that that is a full width less than sign. It's not been compatibility normalized. So, unfortunately, our technique of using that won't let us inject. Now, as well as the compatibility normalization, there are two other forms. There's NFC for composition and NFD for decomposition. Now, we can try a probe, because what we can do is we can put in letter A and then we'll add a combining acute accent, and we'll look at the response to see what comes back, whether it is the single character A with acute accent or whether it is character A followed by combining acute accent. Okay, now this here is the combining acute accent character. It's 0301. Now, if I try to copy that straight from Wikipedia, I'll also copy this circle, which we don't want. So I'll use Windows Charm app and find 0301. Paste that in. Notice the unusual behaviour when I pasted that, in that it added it to the adjacent character. Okay, so we'll submit. And let's take a look at that in a hex editor. And what has come back does not contain the letter A. So this indicates that something has been translated. Now, what I'll do, just to show the difference, I've got the basic reflective lab here. So if I put in an A, and again the combining acute character, I can submit that, and this character in the response, if we look at this in the hex editor, you can see we've still got the A, and then we've got CC81. Now you may be thinking, hang on, did we not put in 0301? And we did. And what CC81 is the UTF-8 encoding of that letter. Now I won't go through the steps to decode this, but what we can pick up is that C3A1 is the UTF-8 encoding of that single character A with acute accent. Okay, so we're done with that, done with that, done with that. So let's look again at what we've got. Now we know that Unicode normalization NFC is being applied, and this is our data, and it's right next to this greater than sign, which terminates the text area tag. Now, a question we can ask is there any combining character which will combine with greater than and turn it into something else? And let's do a quick bit of Python to investigate this. So we can import Unicode data, And if we go through, well, we'll go through the first 64k Unicode points. And what we'll do is we'll do Unicode data normalize form NFC, and then greater than, and then the particular character we're looking at, and then if not n starts with, if the normalized string doesn't start with greater than, we can infer it's translated it somehow. And then what we'll do is we'll print the hex code of the character, and we'll print string. Okay, and straight away it's come back 0x338. So let's have a look at what that character is. So 0x338, and this is a combining bar or stroke, and we can see that it combines with the greater than symbol into the not greater than symbol. Okay, so this is potentially really useful. So if we find 338 and copy that, now we can go back here. We can start with the combining slash. I'll just put in some text. Notice that the browser actually struggled to render that properly. Right, now something has happened, and let's look at the source. And again, in the source it's struggling to render it properly, but we can infer that we have done something to the tag. So let's go back, and then instead of test, what we can do is we can use the on focus trick that we learned about earlier, because we're injecting into a tag. So we've got the combining slash and then space on focus, and let's get our JavaScript payload. And auto focus, and then we'll close the tag, and we know that greater than isn't escaped. So with any luck, our payload will now execute. Okay, so let's grab that URL, and just to be completely sure, let's submit our payload to the headless browser, and there you go, we've solved the lab. And this is what the source code looks like, and what this relied on was NFC normalization. And just to be clear, if the app had normalized our string and then put it in the HTML, this wouldn't have been vulnerable, because we couldn't have affected the greater than sign here. So what we can infer has happened is the app has combined our input with the HTML, and then it's performed NFC on the whole thing, and in doing that it's introduced a vulnerability. Now this is just a theoretical lab. I've never seen this behaviour in a real world application, but I hope this is still useful to you because it illustrates some interesting techniques.